this video, we're going to talk about what's called a one-sided derivative. These derivatives have similar properties to limits in the sense that if the derivative from the right equals the derivative from the left, then the derivative will exist. The derivative cannot exist if the derivative from the left is different than the derivative from the right. So here comes the definition of a one-sided derivative. A function y equals f of x is differentiable on a closed interval a to b if it has a derivative at every interior point of the interval and if its limits, the limit from the right and the limit from the left, exists at the endpoints. So what this means is that basically the same rules as limits. For the derivative to exist, the limit from the left has to equal the limit from the right. But more importantly, it has to be the limit of the difference quotient. So while the limit might exist, the derivative might not. So now we're going to look at an example of a problem where the derivative does not exist, however, the limit does. So this is the piecewise function of x squared if x is less than 0 and 2x if x is greater than 0. So you can see that the limit from the left is equal to the limit from the right. But now what we're going to do is we're going to talk about the derivative, and remember the derivative is the slope of the tangent line. So right now I'm going to graph the derivative. So this is the graph of the derivative, and you can see right here the derivative goes from being a negative number to all of a sudden being 2 because this is y equals 2x. So this is 2, and then it jumps down here. And since there is a jump here, the derivative from the left does not equal the derivative from the right. And now to explain that algebraically, we're going to go back and actually solve this out. Alright, example 5. One-sided derivatives can differ at a point. So we're going to use that piecewise function that we just saw in order to do the left-hand derivative and the right-hand derivative. So the left-hand derivative, and that's this one here, because it's when x is less than 0, we're going to do the limit as h approaches 0 from the left of f of x plus h minus f of x all divided by h. And so we get that f of x is equal to x squared. And so we get that f prime of x is equal to 2x. So the derivative of x squared is 2x. And now we want to know the derivative at 0. So f prime of 0 is just equal to 2 times 0, which is 0. And now to check that, we need to do the derivative from the right. So a right-hand derivative. And this is going to be the limit as h approaches 0 from the right. And again, it's not really from the right, but I put that there for notation. It's just as h goes to 0 because it's the distance between 2 points. But I put that there just to remind me I'm doing the right-hand limit. And this is f of x plus h minus f of x all divided by h. And our function for this one is f of x is equal to 2x, because this is when x is greater than or equal to 0. So we get this is the limit as h approaches 0 to x plus h minus 2x all divided by h. So this means that the derivative from the right is equal to 2. And so if you notice, the left-hand derivative which is 0, and the right-hand derivative, which is 2, are not equal to each other. So therefore, the derivative does not exist at x equals 0.